Welcome to PhilSci Hub Research University, your ultimate guide on your next research project.
We will lay down the best practices in research ideation, literature review, experimental design, and data analysis to guide you as you carry out your research project. Learn from the PhilSci Hub team of research scientists and some invited subject matter experts. PhilSci Hub Research University will be your personal coach through every stage of your research project, from ideation to final assessment.
And the best part, it's absolutely free.
Visit us at philscihub.com and be part of this learning journey.
Let's learn and succeed together here at PhilSci Hub Research University. Welcome to PhilSci Hub Research University, your ultimate guide on your next research project.
We will lay down the best practices in research ideation, literature review, experimental design, and data analysis to guide you as you carry out your research project. Learn from the PhilSci Hub team of research scientists and some invited subject matter experts. PhilSci Hub Research University will be your personal coach through every stage of your research project, from ideation to final assessment.
And the best part, it's absolutely free.
Visit us at philscihub.com and be part of this learning journey.
Let's learn and succeed together here at PhilSci Hub Research University.
Mabuhay! Welcome to the Filipino Science Hub. Thank you for your continued support to this online platform. To our new participants, thank you for checking us out today, and we would like to officially welcome you to the PhilSci Hub family. Before we start the webinar, I would like to share some house rules in order to facilitate a smooth session. For our Zoom participants, we would appreciate it if you could turn your audio and video cameras off during the webinar. If you have questions or comments, feel free to type them on our Zoom chat box or YouTube live comments, and we will try to accommodate as much questions as possible. After the talk, we will have a 30-minute Q&A where the Zoom participants will have the opportunity to ask their questions live. For those who would like to receive a certificate of participation, a Google form link will be posted on our Zoom chat box, YouTube live comments, and YouTube video description towards the end of the webinar. Again, welcome to all our Zoom participants and YouTube live viewers. For those who are new and may not be familiar with who we are and what we do, allow me to share our mission and vision in the next few minutes. Filipino Science Hub is an online platform founded by our CEO, Filipino scientist, Dr. Jeffrey Camacho Bongkin, back in 2012. Currently, we are a registered nonprofit organization based in Houston, Texas, United States. Our mission is to promote STEM education and the culture of research among students and teachers in the Philippines and abroad. Our current global leadership team is comprised of volunteer Filipino scientists, seasoned STEM educators, and business executives across the globe. Our vision is to see a technology and innovation-driven Philippines, and we believe that this can be achieved by creating a new generation of well-rounded Filipino STEM enthusiasts. The vision is being carried out via our two major programs, the PhilSci Hub Ed program and the PhilSci Hub Research University. Through PhilSci Hub Ed, we are able to empower and support our teachers by strengthening STEM fundamentals education. We believe that this is important because the more equipped our STEM educators are, the more they can inspire students to pursue a career in science, technology, engineering, and mathematics. The other major program that drives our vision forward is PhilSci Hub Research University. This is where we provide tools for fundamentals of research and bring practicing scientists closer to the educational sector. Our official website is www.philscihub.com. This is where you can access all our materials such as webinars, tutorials, modules, virtual lab, and features, all of which are free. We are also present in several social media platforms, so follow us wherever you are most active on to get updated with our web events. Again, thank you for being with us this morning. To officially start our webinar, I would like to turn the virtual floor over to our host today.
Ayan, magandang umaga po sa inyong lahat sa Pilipinas and to those who are dialing in from different parts of the world. Welcome to today's session. So maraming salamat po sa muli ninyong pagsama sa amin. It's been a while since we had a chemistry lecture or tutorial. The last one that we had was in March of this year. And at this point, I would like to call on like my partner for today's episode. So Dr. Connie Hibas. And so, but before we actually proceed to our session for today, we'll start with introduction. So, ako muna po yung mauuna. So, I am Jeffrey Buntin, and I'm the current, and I'm the founder and CEO of Filipino Science Hub. So, ako po ay isang Filipino scientist, chemist by training, in particular, in case you're curious. And I'm based here in Houston, Texas. And today we're actually joined by Dr. Connie Hibas. Dr. Hibas, would you like to introduce yourself as well?
Hello, I'm Connie Hibas. Ako din ay based dito sa San Antonio, Texas. And I am a mycologist. So that means I study fungi. So if you don't know what mycology is, that's what it is. Fun guys and fun girls.
Yeah.
Okay.
And just like everyone here, Dr. Hibas is also going to be a student of chemistry, as she mentioned earlier when we were setting up the session. So yeah, so we hope that you enjoy today's session po. So this is the 5th episode of a Filipino Science Hub program called Chemistry Made Easy. So before we move on to the talk proper, I would just like to say a few things about this program. So can you see my screen, Dr. Hibas, like the full presentation? Nakikita niyo?
Yeah.
Okay. So everyone, welcome to Chemistry Made Easy. So this is our 5th episode, and for today, we will be focusing on chemical reaction. So and this episode will feature a very special chemistry educator, especially to me, kasi napaka-personal po nito. Ang ating pong lecturer for today, siya po ang ating organic chemistry teacher / mentor. So kung ano man po yung masashare ko sa inyo is actually one of the people behind the learning and yung approach po sa pag-aaral at pagtuturo ng chemistry. So he is one of those influences. All right. So, okay, why are we doing Chemistry Made Easy? So ang goal po natin dito is essentially, kumbaga baliin yung typical notion or yung reputation ng chemistry sa mga guro at sa mga mag-aaral na, oh, it's chemistry, mahirap yan. O, ang hirap mag-memorize ng periodic table, ang hirap mag-memorize ng reaction. So, yan po yung gusto namin baguhin. Kasi ako po, for example, I'm a chemistry major. I'm a chemist by training and I'm using chemistry and most especially fundamentals of chemistry in my daily life, like as a practicing scientist. So, ang gusto po natin mangyari is tanggalin natin yung, kumbaga yung maling notion or impression ng mga tao when it comes to chemistry. So, ang gagawin po natin dito sa Chemistry Made Easy series is first, we are going to democratize chemistry concepts. So, essentially, we're gonna simplify it. So, kung ang experience po ninyo sa chemistry or yung previous experiences ay kumbaga medyo nahirapan kayo intindihin yung lengguwahe, yung pagkakaturo, this is a program that's gonna deliver to you siguro the most relatable way ng pagtuturo ng chemistry. So, Tagalog English for example, situational, yun po, examples based. So hindi this is not gonna be your typical chemistry lecture where magchuchok-tok tayo na mention lang namin yung concept tapos bahala na kayo. No, hindi ganyan yung approach namin. So we're gonna make this experience easy and enjoyable for students, most importantly. And then along the process, yung ating lecturer then he will share tips not only on how to learn chemistry, and our speaker for today is a chemistry instructor. So I know for sure that he will also mention some teaching tips and practical and effective teaching methods. So I have seen this presentation and I know that you guys are in for a treat. So disclaimer lang po, so this session was made for a diverse set of audiences. So if you are an expert, you might not need this. But ang intention po namin dito is for this to be a refresher course sa ating mga guro, and for this to be a tutorial, a fun tutorial for students. So again, we'll focus on on basic principles. In certain instances, our speaker will also provide some examples or analogies. So yun po yung mga bagay na dapat po ninyong bantayan. All right, so before we move on to the session, I would just like to do the honor of, not do the honor yet, but I would like to also share with you if the screen would load properly. So sa slide po na ito, for some reason yung, ayan, nagpapakita na siya. So Chemistry Made Easy, we already have rolled out 4 episodes po nito. So over the course of a year and a half. So yung pong una natin na 4 episodes which I delivered myself tackle concepts of the concepts such as the atomic theory, oxidation states and balancing redox reactions, Lewis structures, and mole concept. So yan po, Tagalog, English, simplified approach sa pagtuturo at sa pagkakatuto ng mga chemistry concepts na yan. And so for today, we'll have our 5th episode. And para naman po hindi kayo magsawa sa akin, nag-imbita po ako ng napaka-espesyal na instructor or tutor ninyo for today. And it is with great honor that I introduce to you Dr. Chester Lara Dabalos. So sinabi ko kanina, siya po ang aking chemistry laboratory instructor, most especially sa organic chemistry. So Dr. Dabalos graduated from the Bachelor of Science in Agricultural Chemistry program of the Institute of Chemistry at the University of the Philippines, Los Baños. So he graduated cum laude and he ranked number 1 sa chemistry licensure exam in the same year. And ito lang po, magkukwento lang ako. So I started my chemistry degree, in the chemistry program UPLB in 2002. So pagpasok ko sa UPLB, ang una ko nakita was yung banner that says, "Congratulations, Chester Dabalos, top 1 in the chemistry licensure examination." So hindi ko pa siya nagiging teacher, kilala ko na siya. And true enough, when he became my organic chemistry laboratory instructor, I was one of those fortunate students to have experienced someone like him who I think to this day remains to be one of the most passionate chemists that I have met in my entire life. And kapag naka-encounter ka na ganyan teachers, it changes you. And this is also the reason why I invited him to do this, because it would also be great for students and teachers in the Philippines and everywhere else from other areas to experience his brand of teaching. So I'm hoping that you also get the exact same influence and inspiration that I got from him. Okay, so yun po, undergrad pa lang, humahataw na. And then in 2005, he actually finished his Masters of Philosophy or Organic Chemistry, I think to be specific, sa Cambridge University. So in case po hindi kayo familiar sa Cambridge University, so Cambridge University is actually one of the top universities in the world. So laging nasa top 5 lang siya. Number 1, number 2, number 3, papalit-palit lang yan every year. So ang atin pong speaker ngayon ay nakapasok sa ganyang kataas na paaralan. And then he didn't stop there. So he actually finished up his Doctor of Philosophy degree in biophysical chemistry. So ano po, biology, physics, and chemistry pinagsama-sama niya. So namamakiyaw po siya ng specialization. So he earned this degree from the University of Hawaii in Manoa. And at the moment, he is a chemistry instructor at the University of Hawaii. So nagstay po siya doon. And then he's been teaching for more than 10 years already. Okay. So at this point, it is with great honor that I introduce to you my mentor and one of my greatest influences, Dr. Chester Dabalos. Dr. Chester, take it away.
Hello. Salamat po, Jeffrey, sa iyong introduction. Salamat po, Tita Connie, for being with us today. And sa lahat ng mga nanonood, thank you very much. Ito ay isang napakalaking karangalan para sa akin at nabigyan ako ng oportunidad para ipamahagi sa inyo ang aking nalalaman sa kimika or sa kapnayan, the way we call it in Filipino. So thank you very much. So hopefully ngayong hapon mabibigyan ko kayo ng how would I say yung mga things that I really uphold. Makikita ninyo yung philosophy ko, I mean on how I teach chemistry. So hindi lang concepts, pero makikita ninyo that how I actually use yung everyday experiences natin para ma-appreciate ang chemistry. Tapos may mga ibang pedagogical tips. So I really intended this lecture, I mean sa mga guro na katulad ninyo kasi gusto naming i-outreach yung parang yung passion namin at interest sa chemistry. So the way I give my lecture, I usually ask some questions. I mean kung gusto niyo sumagot, I mean pwede niyong sagutin. Kung hindi naman, pwede kayong maglagay na lang ng mga emojis sa screen or pwede niyong tanungin towards the end. Tapos ng ganyan. Pero kung kating-kati na kayo or gigil na kayo na magtanong, I mean, pwede namang i-unmute niyo na lang yung sarili niyo. Or pwedeng i-type nyo na lang sa Zoom kung yun ang gusto niyo. So gusto niyo na bang magsimula? Okay, so i-share ko na ang aking screen. Okay? So okay. So bababa ko siguro ito. Okay. So ang aking paksa ngayong hapon na ito ay ang chemical reactions. Okay? So i-share ko muna ang aking outline. So yung plano kong i-deliver. Tapos iisa-isahin ko ang mga ito. So una, magbibigay ako ng mga halimbawa ng chemical reactions. Kung nagbibigay ako ng halimbawa sa aking mga estudyante, ginagamit ko ang mga bagay na pamilyar sa kanila. So mga pangkaraniwan. So syempre, ayaw ng mga estudyante na parang napaka-abstract yung mga concepts. So dapat yung nararamdaman nila at na-experience na nila. Tapos, second part, i-define ko kung ano ang chemical reaction. Pagkatapos noon, ang mga pamantayan ng isang chemical reaction. Pag sinabi natin pamantayan ng isang chemical reaction, ito yung mga physical observations. Okay? So magbibigay ako ng 6 na pamantayan. Tapos, didiscuss ko ang mga uri ng chemical reactions at karagdagang halimbawa. Tapos, sa huli, magbibigay ako ng maikling pagsusulit. So, mga two questions, tapos mga may sub questions ang mga ito. Okay, so umpisahan na natin. So, ano nga ba ang mga halimbawa ng chemical reactions? Okay, so sino sa inyo ang mahilig mag-bake ng cake dito? May mahilig mag-bake ng cake? So kung gumagawa tayo ng tinapay, pwedeng ang kadalasang ginagawa natin ay naghahalo tayo ng baking soda at tartaric acid, okay, para makabuo ng carbonic acid. Tapos tong carbonic acid na ito ay nadidecompose sa carbon dioxide at water. So ito ay isang halimbawa ng chemical reaction. Okay? Pangalawang halimbawa ng chemical reaction ang pagkalawang ng metal. Okay? So say for example, may mga pako diyan sa tabi-tabi, kung ito ay nabasa ng tubig at hayaan lamang makakontak ng tubig, usually ito ay nangangalawang. So nakikita natin na yung shiny na pako, after a few days, ito ay nagiging brown na. So ito ay actually isang halimbawa ng chemical reaction. So alam natin itong pagbula at saka itong pagkalawang, okay? Kasi nakikita natin ito sa ating pang-araw-araw na buhay. Okay. Mga halimbawa pa ng chemical reactions, say sa industriya, okay? So sa industriya, nagmimina sila ng metal, okay? So ano nga ba ang metal? Usually ang mga metals are shiny objects. Pero ang mga metals na ito ay hindi mo naman nahuhukay ang shiny na object sa lupa. Usually they are in the form of an ore, okay? So a metallic ore. So katulad ng example na ito sa left hand side ng iyong screen. So meron tayong bauxite, okay? So this is an aluminum oxide. So brownish ang itsura, tapos pinaprocess ito sa planta para maging aluminum. Okay? So yung aluminum, ito yung whitish shiny metal na aking binibilog-bilugan. Okay? So ito. So ang pagmiminang ng metal, ito ay isang halimbawa ng isang chemical reaction. Okay? At saka ang panghuling halimbawa na i-discuss ko sa slide na to ay ang paggawa ng pintura. Okay? So say yung mga bright colored paints, usually minamanufacture ang mga ito using a chemical reaction. So ang example ko dito ay dilaw na pintura na hango sa LED. Okay. So ito ay onting halimbawa. Okay. So ang next natin na tanong, paano natin malalaman or ano ang basehan para sabihin natin na may chemical reaction? Okay? So ano ang kahulugan ng chemical reaction? Okay? So ang chemical reaction, okay, ito yung napaka-importanteng definition. Ang chemical reaction is where we are going to break, okay, or form chemical bonds. Okay? So ang pagputol at pagbuo ng bonds. Okay? Usually ang chemical reaction is going to manifest itself, okay, in some forms, katulad ng pagbula na nakita natin kanina. Okay? Magbibigay ako mamaya ng iba pang pamantayan, okay, ng chemical reaction. Pero pwede nating i-describe ang isang chemical reaction into three, okay? Into three levels, okay? O mga antas, okay? So, uunahin ko ang pinaka-common, okay? Ang pinaka-common, okay, para i-describe ang isang chemical reaction is through an equation form, okay? So ito yung kadalasan nakikita natin. So say for example, itong pagbula, okay? So H2CO3, so yun yung formula, chemical formula ng carbonic acid. Tapos pag nakita ka ng arrow, okay? Itong arrow sign, okay, sinasabi niya na itong H2CO3 ay magiging H2O at CO2, okay? So H2CO3, medyo tongue twister. Ito yung reactant mo, okay? Tapos yung products mo yung nasa right hand, okay? Ito yung H2O at CO2. Okay? So yun yung kadalasan na ginagamit, okay? Pero as teachers, okay, paano ko ba 'to sabihin? Meron tayong dalawang uri ng estudyante. May mga estudyante na medyo mathematical mag-isip, okay? Kung saan bagay ang equation form. Pero may mga estudyante naman tayo na medyo artistic mag-isip. So, ang ginagawa ko sa aking klase, okay, so hindi lang equation form. Binibigay ko rin yung molecular level. Paano mo pine-present yung equation form in terms of, say, something na pwede na lang ma-imagine. Okay, so ito yung molecular level, okay? So pwede kang gumawa ng mga, say, ng mga building blocks in order to represent represent H2CO3. So okay, so ito yung mga H2CO3. Okay, usually yung mga atoms are actually represented by colored spheres. Okay, so say yung carbon, ito yung black, tapos yung red, okay, ito yung oxygen, at saka yung maliit na parang off-white is hydrogen. So pwede kang mag-show ng mga models, okay? Tapos pwede nating on the right hand side ipakita naman yung mga products, okay? So H2O, okay? So bibigyan ko lang ng kulay para mas clear. So H2O, okay? Tapos CO2, okay? Okay, so ganito yung ginagawa ko. May equation form ako at saka may parang may visual representation in order to suit all types of students. Okay, so equation form, molecular level, and yung mas advanced, ito yung tinatawag na structural level. So nakita ko may lecture kayo with Dr. Bungkin about Lewis structure. So medyo mas advanced ito kasi gagamitan mo ng Lewis structure, yung pagre-represent ng mga molecules. Okay, so say for example, itong H2CO3, makikita natin na ito yung structure. So makikita natin na may double bond, may single bond, okay? Okay, so tapos ng ganyan yung products niya, CO2, okay, and water. So makikita natin yung mga double bonds at single bonds. Okay. So ang isang chemical reaction, okay, may chemical reaction na nangyari kung may naputol o nabuo na bonds. Okay, so suriin natin kung ano yung mga bonds na naputol. Okay, so pwede kong maybe bilugan ito ng asul. Okay, so naputol ito. Okay? So naglagay ako ng kidlat doon. So naputol. Siyempre kung may kidlat, 'di ba? May pag tumama sa puno, mapuputol talaga yung puno. Okay? Tapos may mga bonds din, may bond din na nabuo. So itong magenta na nilagyan ko ng asterisk, ayan yung nabuong bond. So ang chemical reaction talaga kailangan may naputol o namuo na chemical bonds. Okay? At isa pang importanteng malaman ninyo, yung reactants, okay, at saka products magkaiba, okay, yung chemical formula. Okay? So magkaiba yan. So yun yung kailangan ninyong ma-recall kung nagdi-describe kayo ng isang chemical reaction. Okay. Now, tignan naman natin ngayon yung mga iba't ibang pamantayan or physical observation ng isang chemical reaction. Bakit nga ba? I mean, bakit kailangan natin ng physical observation? Of course naman, pag nakakita kayo ng reaction, hindi mo naman nakikita yung molecular level, di ba? Nai-imagine mo lang. Pero ang nakikita mo, may basis ka, meron kang observables. Okay, so ang next ko na ipapakita sa inyo ay yung mga observables. Okay, paano natin masabi na may isang chemical reaction? Ito ngayon yung manifestations of a chemical reaction. Okay. Number one, yung pangunahing halimbawa natin ay pagbula. Okay. So ito yung pag-agnas ng carbonic acid. Okay. Pangalawang pamantayan ng isang chemical reaction, pag-init ng kapaligiran. Okay. So evolution of heat. Okay, so sino sa inyo ang mahilig pumunta sa Quiapo at magsindi ng kandila? Ano ang temperature doon sa harapan ng altar, 'di ba, mainit? Okay? So bakit umiinit? Kasi may chemical reaction na nangyayari. Ito yung combustion, okay? Combustion ng paraffin doon sa kandila. Okay? So yung pangalawa, pag-init ng kapaligiran. Okay? Mag-move naman ako sa pangatlong pamantayan. Ito ang pag-iba ng anyo o itsura. Okay? So, ang example na binigay natin kanina ay yung mga pako na nangangalawang. Okay? So ito rin ay napakahalagang definition ng chemical reaction. Yung chemical properties, okay, ng product mo ay magkaiba sa chemical properties ng reactant mo. So ang product natin kanina doon sa sa pangangalawang ay yung kalawang, rusted iron, right? Tapos yung chemical properties ng starting material mo, yung shiny na metal. So magkaiba ang anyo at itsura nila. Okay? Kaya masasabi natin na may chemical reaction. Okay? Pang-apat, siguro paborito natin lahat ito kasi summer. Okay? Pag-iiba ng kulay at pagkakaroon ng ibang amoy. Ito ay pinapamalas sa atin ang paghinog ng mangga o paghinog ng prutas. Okay? So syempre, kung hinog na yung prutas, okay? Usually iba yung kulay at saka ang bango-bango ng prutas na yon. So pwede nating sabihin na may chemical reaction na naganap. Okay? So I'm going to move now to my fifth pamantayan. Okay? Ang pagbuo ng chemical na hindi matunaw. Okay? So sino sa inyo ang mahilig maglaba dito? Usually, nung nasa Pilipinas pa ako, isa sa mga paborito naming na sabon ay perla. Okay? So, ang perla ay actually hango sa mantika ng niyog. Okay? Ang perla ay actually usually ginagawa, minamanufacture ang perla, ang sabon, using a chemical reaction. Of course, yung product mo, yung sabon, hindi ito well matunaw unless kuskusin mo at gamitin mo na sabon. Okay? Tapos yung last na pamantayan ng chemical reaction ay ang pagkaroon ng ilaw, okay? Or evolution of light, okay? Nung bata-bata pa ako, I mean kung summer din ang saya-saya tignan ng ang mga puno kung gabi kasi ang daming alitap-tap. Okay? So sinasabi ko sa sarili ko, ayan na yung mga fairy lights. Okay? So yung alitap-tap or firefly, okay? May chemical reaction na nangyayari sa kanilang katawan para ito ay magkaroon ng ilaw. Okay? So meron tayong 6, okay? 6 na pamantayan ng isang chemical reaction. Okay? Meron kayong tanong before ko i-introduce yung next na subtopic? Okay. So now, tignan naman natin ang iba't ibang uri ng chemical reaction, okay? So paano so mga guro, the way na magturo tayo, sometimes usually pwede nating sabihin, paulit-ulit na lang na ginagawa ito. Pero para hindi tayo ma-bored, dapat nilalagyan natin ng dimensionality, okay? Every time na nag-teach tayo. So we are going to build, one level after another. So kung, parang bigyan natin ng kulay, okay? Para hindi tayo ma-bore at hindi rin ma-bore yung mga estudyante natin. Okay? So ito ang mga uri ng chemical reactions. Okay? Magbibigay ako ng 4. Okay? 4 na uri, tapos yung last 2 ay may subcategories. Okay? So babangkitin ko muna in passing ang mga ito, tapos ng ganyan atin susuriin each one of them, okay, in the next few slides. Okay? So first, okay, first is combination or synthesis. Okay, so by the word combination, may i-combine ka, may paghahaluin ka. Okay, so meron akong dalawang, again similar to what I have done a while ago. Meron akong dalawang representation. So first, okay, ito yung tinatawag ko na general equation, okay? A plus X will give you AX, okay? So general representation or a general equation. Tapos, okay, meron naman akong visual representation. Okay, so palaging ganon, okay? So nakita natin na may combination yung red at saka green na ball, okay? Next type of a chemical reaction is decomposition. Okay, so AX to A plus X. Okay, or makita natin yung representation niya. Okay, so usually kung nagbibigay ako ng mga sinang list, ang ginagawa ko, hindi ko lang sinasabi yung list. Ina-associate ko yung components ng list. Okay? So how do I associate this? So pwede kong sabihin na yung combination at synthesis, a combination or synthesis is essentially the opposite of decomposition. Okay? So again, so hindi lang kayo magbibigay ng listahan, dapat kino-connect mo yung mga components ng listahan na yon. So I could actually just simply think of this as one, but both of them will be in the opposite direction. Okay? Para hindi lang memorize. Okay? Now, punta tayo sa third type ng chemical reaction. Ito yung single displacement. Okay? So A plus Bx to Ax plus B. And of course, meron tayong a visual representation. Okay? So single displacement. Okay? So single, magpapalit ka lang ng isa. Okay? So yung A, papalitan mo si B. Okay, so single displacement at meron tayong dalawang subcategory. So first one, meron tayong reaction ng metal at acido. Second category, subcategory, meron tayong reaction ng metal at isa pang ionic at isang ionic compound. Okay. Now fourth one, meron tayong double displacement. Okay? So double, magpapalit ka ng dalawa. Okay? So isipin nyo palagi, sabihin nyo sa mga estudyante ninyo, huwag kayong mag-memorize. Tignan nyo yung word by itself. I mean, it is going to reveal its meaning. Okay? So huwag kayong mag-memorize. So double, so kailangan dalawa. Okay? So AX plus BY is going to give you AY plus BX. Okay? So nakikita mo may shuffling ng partners dito. Okay? At ang subcategories nito ay neutralization and precipitation. Okay? Or kung ako ang tatanungin nyo, usually itong 3 and 4, iniisip ko na lang na parang displacement as a whole. Yung isa single, yung isa double. Okay? So na-connect ko sila. Okay? Okay, so umpisan natin yung discussion ng first type. Okay. So oops. Okay? So ang combination o synthesis kailangan usually or kadalasan talaga, I mean may pagbuo ng bagong chemical bonds. Okay. So isa pang tip sa mga teachers, okay? So wag niyo agad i-discuss yung topic, medyo bigyan niyo ng kwento. Okay? So paano ko to bibigyan ng kwento? Okay? So yung anak ko na magsi 7 years old, mahilig siya actually magbuo ng mga truck, okay? Truck or cars, mga helicopter using Lego bricks, okay? So ang paraan ng pagbubuo say ng truck from the subunits, yung mga maliliit na pieces, pwede natin tong ihalin tulad sa combination or synthesis, okay? Mamumuo ka ng bonds, mamumuo ka ng connections between pieces. Okay? At makita natin, ang pinaka-importanteng paradigm dito ay yung pag-build up ng complexity. So something that is simpler, okay, to something that is more complex. Yun yung team ng combination. Okay? So, sige, magbigay tayo ng mga ng example ng combination reaction. Okay? So binigay ko na kanina yung isang halimbawa ng combination or synthesis, yung pangangalawang, okay? Pangangalawang ng metal, okay? So in an equation form, ito yung reactions ng rusting. So Fe, so hindi alam ko na discuss na ni Doc Jeff yung balancing. So sabihin ko na lang yung reactant tapos product. Okay, so meron kang Fe, okay, iron, O2, so ito yung mga reactants mo, and then yung product mo is Fe2O3. Okay, so yan yung equation form. And usually ang ginagawa ko, binibase ko yung colors, I mean from my representation para ma-associate ng estudyante kasi may mga ibang estudyante napaka-visual nila, I mean in order to learn, okay? So meron tayong equation form, okay? Ngayon, suriin natin yung molecular level, yung antas molecular, okay? So pwede nating makita this may i-describe in this way. So say meron kang Fe, okay? It is represented by those grayish brown balls, okay? Plus, okay, meron kang O2, then magfo-form ka ng Fe2O3. Okay, so nasabi ko kanina, ang mahalaga sa combination synthesis is meron kang formation of new bonds. Okay, so ano yung mga new bonds na na-form? Nakita natin dito na meron kang bagong Fe2 oxygen bonds. Okay, may Fe oxygen bonds ka na na-form. So therefore, this is a combination reaction. Okay. And again, yung ibang hallmark ng combination reaction, so simpler, okay? So mas simple yung FeO2, mas complex yung Fe2O3, okay? At ano pa ang napakahalagang pwede nating ma-describe? Yung properties ng Fe ay magkaiba sa properties ng Fe2O3. Okay? So, yun yung isang pamantayan ng isang chemical reaction. Okay? So, combination, magbibigay pa ako ng isa. Okay? So, siguro yung isang example na ito ay pamilyar sa mga magsasaka. Okay? So, ang abo, okay, isang component ng abo is calcium oxide, okay? So kung nagsunog ka ng kahoy, okay, yung kahoy may calcium, okay? Sinunog mo magiging calcium oxide. Okay, yung calcium oxide pag ilagay mo yan sa tubig, magiging calcium hydroxide yan, at ito ay actually ginagamit sa pag-correct ng acidity ng mga halaman. Okay? So, tignan natin yung equation form. Say, meron kang calcium oxide plus water, meron kang calcium hydroxide. Okay? So, yung calcium hydroxide ay mas simple kaysa mas complex compared to its reactant. Meron pa akong isang way to describe that. Okay? So, pwede nating bilangin yung chemical species involved. Okay? Kung meron kang combination or synthesis, you are going to start from more species. Mas marami. More species. Hindi na ata ako marunong magsulat. More species. Okay? Tapos yung product mo, oonte. Okay? So, dito meron kang 2, magiging 1 siya. Okay? So, usually, isa rin yun that is also one of the ways in order to describe, okay, synthesis. Okay? Bababa yung number of species involved. Okay? Any questions? Okay. Okay, maybe you are going to save it for last. Naku, baka mamaya tutustahin niyo ako ng mga tanong. Okay? Okay, so now punta tayo sa kabaligtaran ng combination or synthesis. Okay? Ito ay decomposition. Okay? Kung may kung ang synthesis, namumuo tayo ng bonds. Sa decomposition, meron tayong bonds na pinuputol. Okay? So, anong halimbawa nito? Well, before ko bigyan ng halimbawa, magbibigay ako ng kwento. Okay? Usually, yung anak ko rin, kung sabi niya, o itong ginawa kong fire truck, mukhang may mali dito. Usually, ang gagawin niya, kakalasin niya. Okay? So, yung idea ng pagkakalas, okay? Actually, pwede natin ihalin tulad yun sa decomposition. Okay? So, decomposition, there's going to be a decrease in complexity. Okay? So, napaka-complex, okay, ng track. Napaka-complex ng track. Tapos, yung products mo ay less complex na siya kasi may mga subunits na lang, mga pira-piraso na lang yung yung mga pieces, okay? So we could also describe it as, ang decomposition, dumadami ang iyong chemical species, okay? So nag-start ka sa track parang isang entity, kung meron kang decomposition, mas marami kang chemical species or chemical entities. Okay. Okay, ito yung paborito natin na na example kanina. Okay lang kung medyo inuulit-ulit yung example, okay? Pero kung inuulit-ulit mo siya, I mean, mas magi-stick sa sa estudyante. Pero wag naman super paulit-ulit at magsusuya na sila. Pero I think this is the last one na na i-discuss ko about yung pagbula kanina, okay? So ito yung pagbula sa paggawa ng tinapay. So magfo-form tayo ng carbonic acid, H2CO3, okay? And then madi-decompose ito to CO2 and water, okay? So again, tignan natin yung mga basehan. Meron tayong iisang chemical species, later on meron kang 1, 2. Okay? So, mas dumami yung chemical species. Okay? Tapos ito yung molecular level na pinakita ko kanina. Okay, pero actually may decomposition reaction ako na alam na paborito nating lahat. Okay. Ano nga ba ito? Ito ang phenomenon ng ripening, okay? So, isa pang halimbawa ng decomposition is yung paghinog ng mangga. Naku, kung nasa Pilipinas lang ako, bibili ako ng isang basket ng mangga tapos magtatago ako sa 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 ilalim ng puno at kakainin ko lahat ng mga manggang ito. So, ang reaction ng paghinog ng mangga ay isang halimbawa ng decomposition. Okay? So, usually, kung meron ka tong green na mangga, okay, yung mga sugars, okay, sa loob ng green na mangga are actually in the form of a polysaccharide. Okay? So polysaccharide, so parang ang daming saccharide units na magkakarugtong. Okay? So ang decomposition, okay, or say ang ripening na ito, okay, is actually a hydrolysis reaction of a polysaccharide. So ano mangyayari dito? Actually, yung magkakaroon ka ng chopping of bonds. Okay? So again, pinakita ko yung kidlat dito. Okay? So i-chop mo yung mga bonds na yan. Okay? Tapos yung product mo ay meron kang monosaccharides. Okay? So poly, marami sila na magkakadugtong. Now you have monosaccharides. Okay? Tig-isang unit na lang. Okay? And usually itong mga monosaccharides na ito, these are actually very, very sweet. Okay? So kadalasan yan, okay, is magkakaroon, you are going to get fructose. Okay? And fructose is the fruit sugar which is really sweet. Okay? Kaya pag habang nahihinog ang mangga, ito ay tumatamis. Okay? Pero wag nating ipatagal pa ang paghinog kasi kung pinatagal mo pa, ang susunod na yan ay ang pagbulok, okay, which is also an example of a decomposition reaction. Okay? Iinom muna ako ng tubig. Okay. Okay, so pupunta na ako sa next na slide. Okay. So yung next na slide, okay, is actually, usually habang nagle-lecture ako, pinapakita ko rin kung nasaan na yung discussion, yung flow ng discussion, okay, para hindi mawala. So may mga signposts ako na nilalagay, okay? So nasa uri tayo ng chemical reaction, merong 1, okay, 2, na-discuss na natin. Usually, kung na-discuss na yan, nilalagay ko sa box tapo para ipakita sa aking mga estudyante ano yung aking next na i-discuss. So ang aking next na i-discuss ay single displacement at double displacement. Okay? Okay, so tip yan sa mga teachers. Okay, dapat hindi pa tuloy-tuloy yung lecture. Dapat may mga signpost tayo para nag-guide natin yung audience natin kung nasaan na yung ating discussion. Okay? Okay, so single displacement. Okay, so alam ko ang mga Pilipino ay mahilig ng party. Okay, so sino sa inyo ang mahilig pumunta sa mga 18th birthday party? Okay, so yung mga debut na tinatawag nila. Walang mahilig pumunta sa debut? Bakit ayaw? Alam ko baka inisip mo.
Nahihiya lang yung mga yan.
Hopefully wala ng COVID, okay? So kung kanina pinakita ko yung combination decomposition using Lego toys. Ngayon, i-describe ko yung displacement reactions similar to a dance. Okay? So, ito yung usual na dance na sinasayaw sa ng party for a debutante. Ito yung tinatawag na rigodon de honor. Okay? So, ano nga ba ang rigodon? Okay? So, rigodon is a Spanish dance. So, ito yung nagpapalit-palitan sila ng partners. Okay? So, actually, habang ginagawa ko to, sinasabi ko, ay hindi lang tao ang marunong sumayaw. Sometimes yung mga molecules din sumasayaw kasi nagpapalit-palitan din sila ng mga partners. Okay? So, i-discuss ko under this category yung single displacement reaction and double displacement reaction. So, yung representation nila is on the right-hand side. So, nakita natin na may swapping. Okay? May swapping of partners. Okay? So, yung A, pinalitan si B. Okay? Yung X, pinalitan si Y. Okay. So, para i-introduce sa inyo ang single displacement reaction, may tanong ako, paano nyo malaman kung peke ang isang alahas? Okay? So, i-connect natin doon sa istorya ng rigodon. Siyempre, kung pag pumupunta ka sa party, kailangan mo magbihis, ano? So, siyempre yung mga iba gagamit yan ng alahas. Okay? So, question. Paano mo malaman, okay? Well, given na sa'yo yung piece of jewelry na yon, paano mo malaman kung ginto or tanso yung piece of jewelry? Okay, so ang answer dyan is we can do an acid test. Okay, so and usually itong acid test din, ginagamit ito as a as an idiom. Okay, so kunwari may pagsubok sa buhay mo, I mean, kadalasang sinasabi nila, oh baka yan na isang acid test na. Okay, yes, yes, Jeffrey?
Wala, natatawa lang ako.
Yeah, so,
Good
yes,
examples.
So yung acid test na yan. So pwede natin gamitin ng acid test para malaman kung peke ang alahas. Kung ito ba ay ginto o ito ba ay tanso. Okay, so tignan natin ang kung tunay na gold, say gold, pero kung peke, usually it is actually made of brass. Okay, brass. So ang brass, okay, at saka gold parehas ang itsura. It's a yellow metal. Okay? Pero yellow alloys actually. So, ang brass, okay, ay zinc halip na gold. Ay zinc sa halip na gold. So, pwede nating malaman, okay, kung brass nga ito by its reaction with an acid. Okay? So, usually may acid test tayo, malalaman natin kung real or fake, okay, by the application of an acid. Ang gagamitin natin sa next slide is a common household acid na alam niyo. Okay, so sabihin ko na sa inyo ang result. Okay, so kung real, okay, the color will not change. Pero kung pagpeke ito ay iitim. Okay? Okay. So, suriin natin tong unang subcategory ng single displacement. Okay, metal with acid. Okay, so kunwari, may piece of gold ka at may piece of brass ka. Okay? Ang kailangan lang natin dito ay datu puti. Okay? So, ang datu puti ay may acetic acid. So, about 2 to 5% ng datu puti ay may acetic acid. Okay? Kung brass siya, which is made up of zinc, magkakaroon ng reaction. So, zinc plus acetic acid will give you zinc acetate and H2. Okay, so nakita natin tong reaction na ito. So, this is a single displacement kasi mapapalitan yung hydrogen with zinc. Okay, so yung zinc magiging partner niya yung acetate. Okay, and yung hydrogen, I mean, is going to be by itself. Okay, so ano ang magiging physical observation ng reaction na ito? Yung brass, iitim siya. Okay? So that's the physical observation. So may change of color. Okay? So if you could remember yung mga pamantayan na diniscuss natin kanina. Okay? So kung totoo yung alahas, walang reaksyon ang tunay na gindo sa asido. Okay? Or kung ayaw mo namang gawin ito, pwede kang mag-improvise. Okay? Paano mo ma-improvise tong test na ito? Pwede mong gamitin yung pawis test. Okay? Kasi yung pawis ng tao ay actually acidic. Okay? So, yung pawis natin ay magre-react, say, sa fake gold or brass. Okay? So, paano mo yung makikita? Usually, ang unang iitim ay yung part ng piece of jewelry that is in contact with the skin. Of course, yung skin, magbibigay siya ng pawis, ay yung pawis ay acidic. So, makikita natin na mangingitim yung mga ito. Okay? So, yun yung application. Okay? Application ng single displacement reaction. You could use an acid in order to test if a gold is authentic or not. Okay. So, the second subcategory ng single displacement, ito ay ang reaction, okay, ng isang ionic compound with a metal, or usually carbon naman hindi metal. But so it's a reaction of an ionic compound with another element, okay, para mas general. Okay, so ang reaction na ito na nakikita nyo sa screen, okay, carbon plus aluminum oxide will give you CO2 and aluminum. Okay, ito yung reaction sa paggawa ng aluminum metal na hango sa bauxite. Okay, so yung aluminum metal, this is a shiny white metal. Okay, and then yung bauxite, yung ore ng iron, is just simply na brownish. Okay? So again, masasabi natin na may chemical reaction kasi magkaiba yung chemical properties ng product, okay? Aluminum versus yung reactant. Yung product mo aluminum, yung reactant mo aluminum oxide. Okay? So magkaibang chemical properties, and usually saan mo ginagamit ang aluminum? Okay, ang aluminum, because it's a metal, it could be drawn into thin sheets. Okay, so it has the property called malleability. Yung bauxite, hindi malleable ang bauxite. Pag dinikdik mo yung bauxite ay mababasag talaga. Pero yung aluminum, you could actually draw that into thin sheets. And maalala mo yung yung aluminum na thin sheets, okay? Usually ginagamit siya sa paggawa ng aluminum foil. Okay? And yung aluminum foil, alam natin kung saan ginagamit ang aluminum foil, di ba? Kunwari pumunta tayo doon sa party ng debutante, kunwari ang handa nila ano ba ang paborito niyong handa? Kunwari lumpia, di ba? So, ginagamit ito sa pag-wrap ng lumpia kung gusto nating mag-uwi ng lumpia. So, si Jeffrey, tumatawa. May naisip ka, Jeffrey. So,
tawag dito, ginagamit yan ni Sharon Cuneta. Ano ba yun? Kantahan mo nga sila.
Ikaw na lang kumanta, Jeffrey. So,
ayan. So, ginagamit po ang aluminum sa pagbabalot.
So, balutin mo ako.
Nag-lecture na ng chemistry, kinakantahan pa kayo.
Ayun, so, habang nag-lecture, sometimes dapat nagpapatawa-tawa din kayo kasi kung hindi, yung mga estudyante nyo, magti-TikTok yung mga yan kasi sabi yung teacher ko napaka-boring. So, kung minsan, dapat i-catch natin yung attention nila. So, para hindi sila mag-TikTok, di ba? Okay. Aha. So, punta naman na tayo ngayon sa double displacement. Okay? So, similar with single displacement, meron tayong dalawang subcategories ng double displacement. Yung una is called a neutralization. Okay? So, ito yung reaction ng isang acid at base. Pag sinabi nating acid, ito yung mga substances na medyo sour. Okay, so katulad ng lemon. Kaya ang base naman, ito yung mga substances na medyo mapait. Okay, so ano ang aking halimbawa ng acid-base reaction? Okay, so kunwari, so kanina, napag-usapan natin yung aluminum foil. Kunwari, nag-uwi ka ng maraming lumpia, tapos ng ganyan, kinain mo lahat, hindi mo binigyan yung mga kasambahay mo. Ano mangyayari sa'yo? Baka kabagin ka, magkaroon ka ng acid reflux. Okay? So, okay, hindi magandang pakiramdam ng acid reflux. Okay? Ano ang acid reflux? Ang acid reflux, okay? So since kung marami kang nakain, okay, mai-irritate yung stomach natin, okay? Magkakaroon tayo ng acid reflux. So yun yung feeling gusto mong mag-vomit, right? So in order to compensate sa excess ng acid sa iyong stomach because of irritation, usually mag-take ka ng antacid tablets. Okay? Usually, ang mga antacid tablets are in the form of calcium carbonate. Okay? So HCl, okay? From the acid reflux plus yung antidote ng acid reflux, which is antacid tablets, may calcium carbonate. Okay, so yung HCl at calcium carbonate magkakaroon ng reaction. Okay, ang reaction na ito ay tinatawag na neutralization reaction. Okay? So neutralization ang tawag kasi magfo-form ka ng neutral na ionic compounds. Okay? So calcium chloride plus H2CO3. At nalaman natin kanina na yung H2OCO3 pala ay magdi-decompose, okay, to carbon dioxide and water. Okay? So kaya ano ang feeling natin pag may acid reflux tayo tapos nag-take tayo ng antacid tablets, usually tumitigab tayo, right? So yung burping, yung tigab na yan is actually the CO2 gas that is formed from the neutralization reaction.
Okay, so in Tagalog, didighay po kayo. So
yan, didighay.
Ilocano po kasi si Kuya. Yeah, so didighay, yan. So that's carbon dioxide, o di ba?
Ako, si Jeffrey, salamat. O nga, yung Ilocano po kasi ako. I would try my best to speak Filipino, pero
and I have to note, I have to comment Kuya Chester. I call him Kuya though siya, mentor ko po si Sir Chester. I call him Kuya because he's like a family to me. But when I saw the content that he's actually put together, nakita niyo po nilapatan niya talaga ng Tagalog. So, ayan. Yeah, please continue.
Salamat. Trying hard po ako, pero okay lang po. Yun. So, yung pangalawang subcategory ng double displacement, this is called precipitation. Okay? So, this is the reaction between two ionic compounds. Okay? So, ang example ng precipitation, okay, ito ay ginagamit sa paggawa ng pintura, lead-based paints, pero hindi na siya gaanong ginagamit ngayon kasi ang lead ay napatunayan nila na toxic. Okay, so magbibigay ako ng example. ng double displacement. So, say lead nitrate plus sodium iodide. Okay. So, ang gagawin natin dito, magpapalit tayo ng partners, right? Okay? So, usually ang ginagawa ko, pinakamadali, sinaswap ko na lang yung dalawang metal components. Okay? So, lead, sodium, yan yung metal mo, sinaswap mo. Okay? So, meron kang sodium nitrate at saka lead iodide. Okay? Now, dapat once lang tayo mag-swap. Kung iso-swap mo na naman yung nitrate at saka yung iodine, magkakaroon ka, it will be the same. Okay? So, once ka lang mag-swap, usually yung ginagawa ko, sinaswap ko na lang yung metals. Okay? So, meron kang lead iodide plus sodium nitrate. Yung lead iodide, ito yung ginagamit nila na kulay yellow na pintura. Okay? Okay, so any questions before I go to the short pagsusulit, maikling pagsusulit? Any questions? Ngayon, I mean, gusto ko namang marinig ang iyong mga golden voices sa pagsusulit. Okay, ayokong answeran ito. Gusto kong marinig sa inyo. So I would really be very happy kung sasagutin nyo ito. So I have two short questions. Okay. Okay. So pagsusulit, banggitin kung anong uring reaction ang sumusunod. Okay, unang tanong, pagdagdag ng tubig sa kalburo, okay? C2 plus H2O to give you CaO plus H2 C2 plus heat. Okay, so sino ang magsasabi sa akin kung anong uri ng reaction ito? Huwag kayong mahiya. Anong klaseng reaction to? So, may apat, okay? Apat na uri. Combination ba ito? Decomposition ba ito? Single displacement ba to or double displacement ba ito?
Kuya, mayroong mga sumagot sa sabi nila, actually there's a few of them who said that double displacement po.
Oh, naku, nakakatuwa naman kayo. So very good. Yes. So it's a double displacement. Okay? So kasi nakita natin may swapping of partners. Very good. Okay. Now, karagdagang tanong. Ganyan ako pag pag nagtuturo ako, pag nakukuha nila yung tanong ko, dinadagdagan ko ng additional na tanong para ma-challenge sila, di ba? So, karagdagan tanong, magbanggit ng pamantayan kung bakit ito ay tinaguri ang chemical reaction.
Okay. So pamantayan daw yung mga yung checks, yung
mga physical observations. Ayan, may nag-chat dyan.
Okay.
Oh, wow. Wow, very good. Evolution of heat. Very good. Okay. So, familiar ba kayo sa reaction na ito? Ito ang nung bata pa kami, kung New Year, ito yung ginagamit sa paggawa ng mga kanyon na kawayan. Okay. Bamboo cannons. Yes. So, sa isang end, meron kang calcium carbide o kalburo. Lagyan mo lang ng water. I mean, pwede kang gumawa ng kanyon. Okay, very good. And that's right. Yeah, so there is another bond that is formed. Yes, that's correct. So yes, I would also accept that. Okay, so may bago kang bond na na-form kasi kanina wala kang hydrogen carbon bond, pero sa products meron kang na-form na bagong bonds. Very good. Okay? And meron akong trivia sa inyo para ma-connect natin lahat ng pieces. Okay? Sino sa inyo ang nakakaalam sa application ng H2C2? Anyone who knows what this chemical is? Ito ay tinatawag na yan. Before ko tignan yung before ko bigay yung sagot. Ethylene, yes, I mean I would accept. Yeah, I mean so
C2H2. Yeah.
Actually ethylene,
may nakuha. Acetylene.
Ethylene or acetylene. Okay? Ethylene or acetylene. Sorry, medyo hindi, baka kinakabahan ako kaya hindi ako marunong magsulat. Acetylene. Okay?
Yep.
So ang trivia, ito ay ginagamit sa paghinog ng mga putos gaya ng mangga. Okay? So pero usually yung mga mangga na pinahinog gawa lang ng ethylene o acetylene, hindi actually kasintamis. Okay? So makikita mo yung kulay ng mangga na natural yung pagkahinog o yung mangga na pinahinog ng acetylene. So, anong difference? Yung sa acetylene, light yellow, pero yung natural na paghinog ay golden yellow. Okay? So, malalaman natin yan. Or, amuyin nyo na lang. Okay? Magkaiba yung amoy. Okay? Yan, natutuwa naman ako sa inyo. Nakukuha nyo yung mga tanong ko. Okay? One last. Okay? Yung one last, so ito yung magiging dessert nila doon sa handaan, 'di ba? Kanina may handa sila na na lumpia, ngayon naman meron silang banana Q. Okay? So, ikalawang tanong, caramelization ng sugar, okay? So, yung unbalanced reaction nasa screen niyo. Okay? So, anong kayang uri ng reaction ito? Ayan, may nag-chat. Aba, tignan mo naman, ang gagaling nila. Decomposition. Yes. Bakit nyo sinabi na decomposition yung reaction?
Okay, ano daw yung mga basehan ninyo?
Yes, mga pamantayan. Okay?
O yun talaga yung Tagalog. Yung basehan is more Hispanic yung origin nun. So, pamantayan, o di ba?
So, sino ang gustong mag-answer nun? Bakit nasabi ninyo na decomposition? Ayan, tignan natin. That's right, may pag-iba ng anyo itsura. That's correct. Yes, decomposition is separated to 3 parts, decrease in complexity. Very good. Ano ka, ang gagaling ng mga guro natin. Okay, so may isang pahabol pa. Okay, break into several forms. Yeah, that's right. So makita natin, okay, yung reactant mo iisang chemical species lang, pero yung products mo meron kang 3 chemical species. So more chemical species, meron kang decrease in complexity. Okay, very good. Okay. So I think that concludes my lecture for today. I mean, it's tamang-tama. I mean, it's almost an hour. So ngayon, meron na tayong mga katanungan, okay, at karagdagang pamamahagi. So open forum na ba?
Okay,
Jeff?
so bibigyan muna natin si Dr. Chester, si Sir Chester ng a few minutes to drink water and to rest his voice. So what we'll do is that we'll just go over one very important announcement, from Filipino Science Hub. So we're going to be promoting an event. All right, let me move on to this. Okay, so Filipino Science Hub would like to invite all of you to Filipino Science Hub Mycology Summer Camp. So this is a fundraising event that Filipino Science Hub is doing for us to raise funds for some of our grassroots projects in the Philippines. So essentially, we have up-and-coming programs where we intend to come up with supplemental teaching materials that teachers and students in the Philippines can actually use para po mas matutunan nila yung mga classes sa science at saka sa math. And specifically, we are designing these materials to help prepare our students para po dun sa PISA type assessment. So ito po ay hindi po ito yung traditional teaching modules or materials na binubuo namin. So these materials intend to first reimagine yung teaching ng STEM, and then at the same time to also teach students higher order thinking skills. So kumbaga hindi lang po to memorization, we are actually coming up with materials na kumbaga po transformative yung magiging epekto sa mga students. So ano po ba itong Mycology Summer Camp? So essentially, this is a series of lecture and training materials that intend to introduce the area of mycology, so the study of fungi, from yung fundamentals, taxonomy and nomenclature, strategies and methods on how to isolate fungi and identify them. And meron po tayong specific course focusing on the identification of aquatic fungi. Our 5th course under this summer camp focuses on strategies on how to publish newly discovered fungus species, and then we will be capping this with, of course, focus on how to take good photographic images and preparation of photographic plates for newly discovered fungus species sa pagpapublish. So ito pong courses na to is actually it will be brought to you by Dr. Connie Hibas, who is an internationally renowned mycologist who's joining us who's with us right now, and Dr. Mark Calabon, who he is a young and up-and-coming mycologist who's recently finished his PhD in Thailand and is coming back to the Philippines at the University of the Philippines, Visayas. So this is open to all teachers and students and STEM working professionals. So again, for 6 courses, 4 Saturdays of July. We'll start the first session on July 9th. At 10 in the morning in the Philippines. So we are accepting registrations up until July 8th, 2022. And perhaps this is also a very good opportunity for us to get a few words from Dr. Connie Hibas kung para saan ba talaga po itong Mycology Summer Camp. Like what to expect. Ayan.
Hindi, may maraming sound. Ang lakas ng kukuklak.
Ayan.
Anyway.
So, yeah. So, Dr. Hibas, like first and foremost, thank you so much for doing this for Filipino Science Hub. And so siguro po, what do our teachers and students and all those siguro STEM enthusiasts like could expect out of this mycology camp?
Okay. In the course of my lectures dito sa Texas, at saka minsan ini-invite ako ng lectures sa mga ibang lugar, nakita ko talaga yung paucity, yung kulang talaga yung information about fungi. So, mycology is a subspecialization of microbiology. So, kung kumuha ka ng microbiology, merong a certain part of that is mycology, which is the study of fungi. So, but sa lahat ng, kahit ako nung nag-aral ako, wala talaga. I mean, what I knew about fungi, there was nothing. So nung pumunta ako sa Japan, wala akong alam. I mean, alam ko yung aspergillus, pero hanggang dun lang ako. Alam ko yung yeast, but I didn't know anything about it. So kahit dito, nung nag-aral ako sa University of Alberta sa Canada, yun ang aking PhD. So I supposedly, kung magpi-PhD ka ng ganon, marami ka nang alam sa masters mo. Kasi going into PhD, you're going deeper into your specialization. Pero ang feeling ko rin talaga, dumb pa rin talaga ako sa mycology. And so, hindi natin mabiblame na wala tayong alam kasi hindi yun ang focus ng biology department. I mean, for example,
Did we lose Dr. Hibas? Ay, medyo ano po. Chester, can you hear me?
Yes.
Ayan. So medyo nagkaroon po yata ng technical issue si Dr. Hibas. But this is an opportunity po for yung mga estudyante pa lang sa atin at a very young age for them to learn mycology. At sa ating mga guro, this is an opportunity for you to learn the basics of mycology and how you can actually perform a research when it comes to fungal identification and classification at kung paano mag-publish. So yun po yung mga kumbaga things to watch out for the like out of this mycology summer camp. All right. So I think nagkaroon ng internet issues si Dr. Hibas. But yeah, we invite you all to check this out. And if you would like to learn more about how to register to this event, punta lang po kayo sa Filipino Science Hub kasi nandun po yung details. All right. So so I was able to fetch one question from YouTube. And so Sir Chester, Kuya Chester, I would like to ask you this. Kasi this is a question that I think, that really merits our attention. So itong question na to, Kuya, sabi niya, paano po malaman ano ang subscript ng compounds when doing reactions? Kasi the person asked this when you showed the calcium carbide example. So paano po ba nalalaman ang subscripts? So siguro magandang mapag-usapan po 'yan.
Okay, so calcium carbide.
Yeah.
So paano ko sasagutin ang question mo? Umpisa na yes, Jeffrey.
Yan. So siguro po dito papasok yung di ba po yung sa chemical nomenclature sa high school, ideally, di ba dapat na i-introduce na yung ano ba yung typical chemical species and yung chemical formula nila. So, for example, siguro po nagulat yung mga, Kuya Chester, na-imagine ko lang na putting myself in that person's shoes, baka nagulat siya dun sa carbide na part, parang paano mo nalaman na C2 yun? Di ba?
Okay.
Baka doon nanggagaling yung question na,
Okay.
paano mo malalaman yung subscript? Ayan.
Okay. So, kung gusto mo ay describe ko yung reaction na yon in terms of Lewis structure, tapos ng ganyan din sabihin ninyo kung enough na yon or hindi. Is that okay?
Yeah.
Okay. So i-share ko, mag-share ako ng screen. Okay. So yung reaction kanina ay calcium carbide, CaC2, okay, plus, okay, plus plus H2O, okay, to give you CaO, okay, plus H2C2. Okay. So actually hindi gaanong mahirap tong reaction na ito kasi nakita natin yung pattern, 'di ba? This is, say for example, pwede nating sabihin na ito yung A X, okay? B Y, tapos ano tong form na ito? Ito yung papalitan mo. So ito ay magiging AY, okay? Ito ay BX, okay? So ito yung general representation. So pero ang question mo, paano mo malalaman yung subscript ng hydrogen? Okay. So kailangan yung knowledge dito ng structure ng calcium carbide. So ano nga ba ang calcium carbide? Ang calcium carbide ay isang ionic compound. Kung maalala ninyo, ito ay actually hango sa calcium 2+ at C2 negative 2. Okay? So ito yung pwedeng nating sabihin na breakdown, okay, ng calcium carbide. So Ca2+, bakit Ca2+? Kasi yung calcium ay nasa second column ng periodic table. Tapos malalaman natin yung charge na negative 2 kasi kailangan mo lang gawing neutral, di ba? So Ca2+, alam mo yan, alam mo na 2+ ang calcium. Tapos yung counter ion niya C2, pero dapat negative 2. Okay, para yung net na charges ay magiging 0. Okay, so ibig sabihin pala yung carbide mo ay something like this. Okay? So may negative 2 ka na charge. So yung first charge, okay? -1 from the first carbon and second charge from the second carbon. Kaya ang net mo ay -2. Okay. So ang mangyayari dito is simply i-abstract niya. So itong negative charge, I mean parang kukunin niya yung hydrogen doon sa water, di ba? So kung gusto nating i-represent, okay, so pwede nating i-represent this way. So pwedeng meron kang yung hydrogen from water, okay? So H2O, okay? So ipipick up lang niya yung hydrogen na ito. Kaya yung formula ng product mo is H2C2. Okay. Usually naman kung nagba-balance tayo ng mga chemical reaction, nilalagay naman yung mga subscript, di ba? Kasi ang subscript parte yun ng identity ng isang chemical. Usually kung magba-balance tayo ng chemical reaction, ang kailangan lang nating i-supply ay yung numerical coefficients. Okay? So satisfied ka ba sa pagsagot ko sa tanong na iyon?
Ayan, okay yan. Tawag dito. So ito po, very important kumbaga tip na binigay ni Dr. Dabalos is that ito po kasing itong balancing and paggamit ng subscript at this hindi niyo po to madaling makukuha if you don't actually know how to also interpret formula in the form of Lewis structures. So yun po yung mahalagang, you have to be able to integrate yung mga topics po na iyan. So, yung chemical formula na nakukuha nyo na nakikita nyo sa chemical equations, you should be able to write them into their corresponding, you should be able to draw their corresponding Lewis structures. Kasi po, kapag, which brings up a very important point. Kapag po ang pagtuturo ng mga guro ng chemical reactions sa mga ito ay gamit lang po ang chemical formula at hindi po siya natatranslate into structures, napakababaw po ng pagkatuto niyan ng mga estudyante, hindi po nila yan ma-retain. Diba? So dito papasok. Siguro Kuya Chester, I would like to bring this up kasi ito po, tinuro sa amin ito ni Dr. Chester Dabalos nung nasa UP kami noon na especially organic chemistry. Organic chemistry is you can represent those reactions in the form of chemical formula, but then at the same time mas tawag dito, mas malalim yung pagkaintindi if you can interpret things or if you can visualize things in the form of Lewis structure. So dapat na-imagine mo ano ba yung bonds na napuputol, ano yung bonds na nare-retain during a chemical reaction. So dyan ko po nakuha yung konsepto ng learning by heart, chemistry by heart. So essentially, if you can imagine yung structure ng molecules, alam mo kung alin lang yung bonds na prone or susceptible sa breaking at ano yung mga bonds na madaling ma-form, wala po kayong hindi niyo po kailangan mag-memorize ng kahit na ano. So yun. And then, integrating the concepts as well of, pinakita ni Sir Chester, tawag dito, formal charges, di ba? Formal charges. Yo. Ano pa, kapag dito doon sa calcium carbide, when you write the Lewis structure ng carbide species, pinakita ni Sir Chester na meron dong negative charges. So ibig sabihin nun, yung negative charges na yun, ang i-attract niya ay yung positively charged or partially positively charged part ng water, which is hydrogen. So yun po. So kung ano man yung mga naturo no, sa mga unang parts ng Chemistry Made Easy, yung fundamentals of polarity, Lewis structures, magagamit nyo yun when it comes to chemical reactions. Kaya po ganyan yung build-up ng topics namin. So ako, nag-start ako dun sa basic concepts. And then dito sa lecture with Dr. Dabalos, siya po yung siya yung nag-present sa inyo. How do you apply that when it comes to chemical reactions? Paano ba nagko-combine yung molecules? Paano ba sila nagpuputol-putol? Yan. Alright. So, okay. Sir Chester, this is actually one of, ito nga yung sinasabi ko na kumbaga simplified approach ng pagtuturo. So kung nakita niyo naman po, si Dr. Dabalos, hinimay niya talaga. So, hopefully po ang ating mga guro sa Pilipinas when it comes to chemistry, sana po karamihan sa inyo ay kaya pong ituro at this level. Sa ganito kasimple na pamamaraan pero mabusisi. Ayan. All right. Kuya Jester, would you like to say a few more things? Like teaching?
Oh yeah, sure, definitely.
Yeah. Ayan. So meron pa tayong question. So allow me to share my screen again. Kasi may mga nagtanong po, do yung mga bata nahihiya sila magpa-reveal ng pangalan So I will be sharing my screen para po ma-share sa inyo, para mapakita po sa inyo yung ilan sa mga tanong ng ating mga students. Ayan. And nakikita niyo na ba yung screen ko? Ayan. So isang question po is, paano po ma-predict yung products ng single displacement reaction?
Medyo, sige.
Ayan. So, would you like to share your screen again?
Oh, sure. So saglit lang. Paano ma-predict? Actually, hindi ko
displacement.
Hello. Actually, hindi ko na nabanggit yung pag-predict ng products ng single displacement reactions. Okay, so simple lang. So kung yung meron tayong dalawang saglit lang. Meron tayong dalawang subcategories, di ba? So metal plus acid. Okay? Tapos meron kang metal plus an ionic compound. Kung metal at acid, okay? Magbigay tayo ng general formula. Okay? So sabihin natin HX, okay? And then M. Okay? M metal. So ang general formula dito ay M plus HX is going to give you MX, okay? Yung MX is actually an ionic compound. Tapos, ang usual na side product nito is actually H2. Palagi, kung meron kang metal at acid, palagi kang may H2. Tapos hindi ko na ibabalance, pero ito yung magiging general, okay? General format. okay, ng metal at acid. Tapos kung meron ka namang metal plus ionic compound, usually isuswap mo lang talaga sila. So pero ang mahalaga kasi dito sa metal at ionic compound, kailangan mong malaman kung anong magiging cation na katumbas ng metal. So sabihin natin M2, Mn plus. Okay? So yung charge ng cation na yon. Usually, tong charge ng cation na ito yung katulad ng ginawa ko sa calcium kanina. Ito ay manggagaling sa column number. Okay? So say for example, kung meron kang Na, ito ay magiging Na plus. Okay? Kung meron kang magnesium, ito ay magiging magnesium 2 plus kasi yung magnesium nasa second column, yung Na nasa first column. Okay? So yun yung metal component. Okay, ngayon meron kang ionic compound. Okay, so kung yung ionic compound mo i-dissociate mo lang yan bale. So kunwari Bx, okay? So magbigay tayo ng say Bx, okay? BXCY. Okay, kunwari yan yung formula ng ionic compound mo. Okay, so ang gagawin mo ngayon is magre-reverse criss-cross ka. So kunwari yung B, ito yung magiging Y plus, okay? Plus CX minus. Okay? Nasusundan niyo po ba? So usually ang ionic compound kasi meron kang cation at saka anion. So kunwari ang cation mo yung B, yung anion mo ay C. So By plus then Cx minus. So ang gagawin mo lang is kukunin mo yung cationic form ng metal mo tapos yung anionic form, okay, ng C. So maggagawa ka ulit ng criss-cross. So Mn plus Cx minus. So yung magiging formula ng product mo ay M, okay, X C sub N. Nag-gets niyo po ba yung explanation ko? Gusto niyo magbigay ng specific example. So ito yung general format. Okay, usually kasi para i-represent ang mga maraming systems, gumagamit ako ng mga notation na to. Pero kung medyo ayaw ninyo, magbibigay ako ng halimbawa. Okay, kunwari magbigay anong magandang halimbawa. Zinc, okay? Plus, okay, anong magandang reaction, Jeffrey?
Ay, Kuya, yung ginamit mo example kanina.
Yung very good. Okay. Very good. Ang galing talaga ni Jeffrey. Okay?
So, student niya po ako talaga palagi. So pag tinatanong niya ako, talagang sasagot po agad ako.
So, pero kasi may carbon. Okay, so okay, bayaran
pero Kuya,
na.
this is also a bit, Kuya, could you write that example but also draw the Lewis structure of acetic acid? Kasi this is a very good teaching opportunity. Perhaps you can erase yung mga nakasulat diyan. But start with zinc and acetic acid para mapakita natin sa kanila.
Okay.
Combine yung Lewis structure and then yung single displacement reaction. How do they recognize which part of the molecule of acetic acid molecule is gonna react?
Okay.
This is a teaching opportunity. Yan.
Okay. So zinc, okay. So acetic acid, ano nga bang acetic acid? So nako, napasabak tayo ng Lewis structure ngayon.
Yan. Para makita nila yan. Kasi kuya, lalapatan natin to ng polarity rin, di ba? Para pag makita nila na, pag nakita nila yung reaction na ganyan, nakakalito kasi ang daming atoms, alin dyan yung magre-react.
Okay,
so siguro po, kuya,
actually, mabuti naman at natanong nyo ito kasi kung maalala nyo early in the slides, meron akong pinakitang structural level. So ito yung structural level na hindi ko nga gaanong in-expound, pero I'm so glad na ito yung naiisip nyong katanungan. Okay, now.
So siguro po Kuya Chester, ako naman bilang student to, ito yung ganito po kasi siya tinuturo sa amin nila Sir Chester back in the days, that you don't have to memorize anything for as long as, alam niyo po ba, ang secret weapon namin as chemists, magaling kami sa Lewis structure and then polarity. Bond polarity. So Kuya Chester, pakitaan mo sa kanila, how can bond polarity give them a clue kung ano yung magre-react?
That's correct. Okay, so tignan natin yung structure ng acetic acid. So, asaan ang pinaka-polar na bond? Or another way to answer that, asaan yung bond kung saan pinakamataas yung electronegativity difference ng dalawang atoms? Okay, so ang hint na gagamitin nyo dyan is every time na makakita kayo ng oxygen, ang oxygen ay napaka-electronegative, okay? So, kung every time na may oxygen yan, kahit anong katabi niya, actually, it's going to become polar, okay? So, since oxygen is very electronegative, it's going to withdraw electron density to itself, okay? Matakaw sa electron ang oxygen, okay?
Mga agaw.
Oh yeah, that's right, mga agaw. So, yung oxygen na yan ay magiging partially negative and yung hydrogen is partially positive. Okay?
Yeah.
Now, ang zinc, ano nga ba ang zinc? Sabihin na lang natin na so ano ang electron configuration ng zinc? So shortcut. So lagay natin argon. 4s2 3d10.
Yan. Oy,
Okay,
nyo memorized yan. By the way, guys.
May periodic table sa harapan ko kasi teacher ako, okay? So usually ang ginagamit okay ng zinc, okay, to do a chemical reaction yung electrons from the outermost energy level. So ito, okay? So may dalawang electrons yan, okay? So ang gagawin niya, okay? Since meron kang dalawang electrons, okay, so this is what you call your electron rich. Electron rich. Yung electron rich, okay, maa-attract doon sa electron deficient. Okay? So parang electrostatic attraction yan, okay? So electron rich is going to be attracted to the electron deficient. So ibig sabihin, i-replace niya ngayon yan. Okay? Mare-replace kaya mapapatalsik ang hydrogen. Pero ang next na tanong nyo, paano ko nalaman na yung formula ng compound ko is something like this? Bakit may 2? Okay, the reason for that kung bakit zinc 2+ is because of the electrons in the outermost energy shell. So kaya yung zinc mo magiging zinc 2+ tapos meron kayong acetate, so close open parenthesis 2.
Okay, so a couple of things rin. So yung pong stable configuration ng metals, for example, when they form ions, dapat aware kayo dyan. Dapat natututunan nyo sa high school na yung stable ion of zinc is may +2 na charge. Yun. And then you should also recognize that an acetate ion will always have a -1 charge. Yun yung stable configuration ng acetate ion. So -1 charge and then +2 charge. So for you to be able to come up with a neutral species, dun papasok yung subscript na pinakita ni Kuya Chester na there's for every 1 zinc ion, there should be 2 acetate ions. So ito po kung mapapansin nyo, sa totoo lang po, ang chemistry ay napakasimple for as long as you appreciate the fundamentals. Pero kapag, again, uulitin ko po, magmumukha akong saramplaka dito, kapag po ito'y memorize nyo lang, ay never nyo po ito talagang maiintindihan ng maayos. So, it's all fundamental sa totoo lang po. Yun po, polarity, electronegativity, may reason po kung bakit yan yung una nating tinuturo sa simula ng klase. Yan po kasi you build on the fundamentals. Hindi niyo po maiintindihan ang lahat ng mga tinuro ni Kuya Chester ngayon kung hindi wala po kayong appreciation ng polarity, ng structure, ng electronegativity. So, yan po, mahalaga po na ma-appreciate niyo yan. And thank you Kuya Chester kasi ito po talagang hinimay niya po ito sa inyo. Ayan. Ayan. So Kuya Chester, mukhang mapapalaban ka kasi meron pang isang
meron pang isang. Naku.
Meron pang dalawang questions dito kasi talagang naging tutorial ito. So let me share my screen lang very quickly kasi but this is actually good kasi yung students ay highly engaged and they're asking, very good questions. Okay,
actually, so sabi ko sa mga students ko, magtanong lang kayo because I'm actually I'm entertained by questions.
Ay, alam niyo po, ito pala, before I share this question, magkukwento lang muna po ako about yung brand ng teaching ni Kuya Chester. So, kapag nagtuturo po yan ng chemistry, he pushes students to integrate yung learning mo in one chemistry subject with other chemistry subjects. So, for example po, nung second year ako, siya yung aking instructor sa organic chemistry. So if you're a student and if you would come into his class or to his exam room, you would expect that the questions will be organic chemistry questions. But then at the same time, kaming mga chemistry students sa second year namin sa UP, we also take up analytical chemistry. So yun naman, mga more on math and yun po, chemical reactions rin, but then you do more quantitative exercises. Pagpasok po namin ng gabi, sa aming organic chemistry lab exam, brown out, nakakandila po kami. Ang question po was a combination of analytical chemistry and organic chemistry. So pag hindi mo nakuha yung analytical na part, hindi mo makukuha yung organic chemistry na part. So ganun po yung klase ng dapat pagtuturo natin ng chemistry na hindi po dapat putol-putol. Dapat po pinagsasama-sama yan. Kasi yun po yung dapat na preparation na magawa natin sa ating mga estudyante. And nung ma-experience ko siya kay Kuya Chester, my life was never the same again. Kasi ganun na yung aking mental exercise sa lahat ng ginagawa ko. How can I relate this thing that I'm doing in a particular area with other learnings that I acquired from a different area. So minsan po kasi iisipin nyo, ay hindi naman to related. Pero sa totoo lang po, ano yan? Yung fundamentals of nature, they have this very beautiful way of working together. Yan. So yun po. Yun lang po yung gusto namin i-share sa inyo. And again, hindi po kayo makakatackle ng complex topics if you don't have a strong command of the fundamentals. Wag mo na po kayong masyado mag-aim ng complex reactions kung yung simpleng concept of polarity and Lewis structure ay hindi po ninyo magawa ng maayos. So yun po. And we have that's the reason why ginagawa po namin itong Chemistry Made Easy kasi hinihimay-himay namin yan from the most fundamental concept hanggang dun po sa integrative kumbaga lessons or topics. Okay, siguro ito, kuya, trick question ba? Siguro sinusubukan tayo nitong student na ito. No? The double displacement reaction, possible din po ba na magkaroon ng no reaction sa product?
Trick question nga ata yan.
Oo, trick question
Kaya
ito.
kung minsan wala naman talagang reaction, sinusubukan lang tayo. Yes, it could be possible. Say katulad nung kanina yung reaction ng golden acid. Wala talagang reaction ng golden acid. So, pwede nating ilagay no reaction.
No. But saka sa double displacement, for example, if you are I'm not sharing the screen, right? Sa double displacement reaction, if you are reacting an insoluble salt, di ba Kuya Chester, with a highly soluble salt, walang mangyayari doon. Kasi the insoluble salt, for example, silver chloride, in water, you won't be able to dissolve it. So it won't be able to perform yung double displacement reaction. So ganun siya. The same holds true. Ito, so challenge ako nitong batang to. You should also read up on concepts of thermodynamically favored pathway. So ibig sabihin, pag yun yung reaction pathway mo, kapag thermodynamically favored yun, ibig sabihin, yung product mo, it's a highly stable one. So yung ability mo to do the reverse reaction wala yun. Hindi siya mangyayari. Kasi hindi siya favored ng nature. So that's more thermodynamics. So I would challenge you to read up on that. Kasi yan yung kumbaga mga further extension nitong concept na ito. So may mga chemical species talaga that you cannot force to react, mainly because they are stable. Ayaw na nilang gumalaw kasi masaya na sila dun eh. Ayun. So just because may inilagay dyan yung na chemical species ang teacher nyo sa exam na mukhang, pwede ito double displacement, you also have to check that out. And this is actually most relevant, siguro sa Gen Chem, in the concept of solubility. Yung solubility rules, di ba, Kuya Chester? So kaya merong classification dyan na this is an insoluble solid. This is a soluble solid. So, yan. So, dapat yung solubility rules memorize niya yan. Kasi dyan yung una makikita yung mga trick questions na yan na say, well, silver, for example, silver sulfide. Would you be able to do a double displacement reaction with sodium chloride? No. Because, for example, yung sulfided salt, that's a very stable one. So, mahirap siya makipagpalitan. So, may mga ganun din. Diba? So, for example, ang analogy dyan, kapag kasal na ang partners, diba? Kahit pa meron dyan mga umaali-aligid, hindi makikipagpalit. Dapat, ideally. Ganun yun, diba? So dapat stable. Ganun yung real life analogy when it comes to these things. Alright. Okay ba? Ayan. Okay. So siguro ito, Kuya Chester, yung last question that I was able to capture. I haven't really checked yung Zoom call as of yet. So ito, see, I don't know which specific type of reaction the student was asking this question about, but sabi niya, does oxidation state play a part in chemical reactions? Ayan.
Paano natin sabihin to? Well, ang oxidation reduction, redox reactions is actually a subcomponent of a chemical reaction. Hindi natin usually dinidiscuss ang oxidation redox reaction kung tinitignan natin itong yung mga uri ng chemical reactions na pinakita ko, kasi mas mabusisi yung treatment ng redox reaction, kasi makikita mo na dito yung mga pagta-transfer ng electrons. Your question, I think the answer is going to be yes. Kasi say for example, bibigyan kita ng example, kunwari yung iron. Okay, yung iron is actually is in two forms, Fe2+ and Fe3+. Okay? So magkaiba yung oxidation. Pero alam mo ba na yung Fe2+ lang ang na-absorb ng body, and the Fe3+ is not absorbed by the body. So actually, the answer to your question is yes. So the oxidation state actually is very important, as a very important determinant, okay, of a chemical reaction as well. Nasagot ko ba yung tanong mo?
Yeah. So siguro actually yun sa context nung mga tinakal ni Kuya Chester, there are some examples that he showed where involved yung redox reaction. For example, yung reaction between zinc metal and acetic acid forming zinc acetate and hydrogen. So definitely, pinakita ni Kuya Chester kanina when he dissected that reaction, that starting from zinc 0, from a neutral zinc species, it ended up being zinc 2+. So nagkaroon ka ng change sa oxidation state from zinc 0 to +2. So yun. There are times that actually marami na, there's a lot of redox reactions out there. Yan. Pero siguro yung pinakita rin ni Kuya Chester kanina was yung neutralization reaction. So neutralization reactions, typically it's hindi siya, in most cases, I'm not generalizing. For example, hydrochloric acid plus sodium hydroxide. Wala yun, hindi yung redox reaction. So punta kayo dun sa tutorial natin, I think episode 3 yata yun, about like balancing redox reactions, and part of that lecture is actually a tutorial on how to recognize redox from non-redox reactions. Ayan. So, diba? Ayan. So, grabe. Kuya Chester, ito may mga nagtanong pa. Ano ba? Ito may... Okay. concerned daw po about molecular or covalent bonding. So there are three principles in the law of electric charges. One, like charges repel. Okay. So paano ito? So Reggie, would you like to ask your question live? Ang haba po kasi ng tanong.
Hello?
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 Oh, okay. Ito, ang tanong ko yung Chester, ang tanong niya pala is, di ba meron daw sa basics of electrostatic, so of three laws of electric charges. So, bakit daw po ang electrons nagko-combine to form bonds kung nagre-repel daw ang negative charges?
Bakit ang electrons ay... Oh, actually, yung formation ng bonds is not just the simple okay. So yung ionic, okay, so there are two types of bonds, yung ionic at saka covalent. Yung ionic is formed by just simply electrostatics. Yung covalent actually mas mabusisi kasi kailangan mo i-consider yung parang kung anong orbitals sila pumapasok. So the treatment of discussing covalent bond formation actually require na tinitignan din natin yung orbitals na na involved, yung atomic orbitals going to the molecular orbitals. So I think your question, pinaghalo mo yung dalawang type of bonds which in fact different yung treatment ng ionic bond at saka covalent bond.
Yeah, so siguro ito si Reggie, I would also encourage you to take up yung lecture namin when it comes to chemical bonding and Lewis structures. Kasi doon namin pinaliwanag yon. So technically two atoms can form bonds if they form so meron yung sinabi ni Sir Chester, they can combine within an orbital. So it's a different kind of treatment. So hindi lang siya yung simple na pagkasamahin mo lang yung electron. So there's a concept of atomic orbitals and molecular orbitals that would come into play. And dun sa molecular orbitals na yun, pwedeng magsama ang dalawang electrons. Diba? So hindi siya ganun ka straightforward ma-explain like in the context of ionic bonding kasi yun, di ba, transfer lang. So ibibigay mo lang siya doon. So yung sharing of orbitals, it has something to do with, okay, yung orbitals na nagko-combine para magsama yung dalawang electrons. And kahit pagsamahin mo ang dalawang electrons within an orbital, meron pa rin tayong considerations such as like spins, di ba, Kuya Chester? There's a bunch of things to consider rin. So ayan, so medyo iba nga yung treatment kapag covalent bonding. So
actually, Jeffrey, ito na siguro ang magiging laman ng chemistry camp natin. So, lahat na ng mga questions, ibigay mo na lahat at aayusin namin papaano.
Yeah, so actually, we will do such a thing. So, January of 2023, we will have the chemistry camp. So, ito talaga, tutorial, will dig deep. So, essentially, all the fundamentals, and ang goal natin is after those 4 weeks, you don't have to memorize any chemical reactions and chemical equations anymore. So, dito papasok kasi talaga yan. So yung sharing of electron, I think we have to discuss that like in a separate topic kasi medyo mahirap kasi i-unload yun at like ito dito sa session na to kasi it requires like going over a few other fundamental concepts. So pero assignment ko sa iyo, kay Reggie, sa iyo na nagtanong, aralin mo yung concepts ng quantum. Yung quantum chemistry. So ano ba yung spins? Ano ba yung konsepto natin ng orbitals? Because those are very important. Okay? Ayan. So, pero like I said, we covered this in part doon sa chemistry tutorial natin when it comes to Lewis structures. Doon pinasadahan ko yun. Actually, pinakita ko paano ba na-form yung carbon-carbon bond? Paano na-form yung carbon-hydrogen bond in organic compounds? So, yun. Alright? Okay. All right. So I guess like at this point, before we end this today's session, again, we would like to promote our summer camp. So we're still accepting students and participants dito po sa session na ito. This is gonna be very fun. So again, fundamentals, Dr. Hibas is here. She will also teach you the art and the science of discovering new species. So actually, trivia po. One of the reasons why Dr. Hibas also wanted to deliver this talk to Filipinos is because alam niyo po ba na karamihan ng mga discoveries ng fungi sa Philippines, which could have a lot of applications sa medicine and a few other areas, ang nakaka-discover po ay mga taga-ibang bansa. So, di ba Dr. Ribas, like napaka-diverse ng Pilipinas when it comes to different species. However, walang masyadong nakaka-discover mainly because kakulang po sa mga eksperto.
Yes.
Yeah.
So tayo sa Pilipinas, grabe ang ating diversity sa fungi. And I will tell you that in my webinar. Pero ngayon pala sasabihin ko na, meron tayong mga 10 to 12 million species of fungi. Ang alam lang natin sa buong mundo, ang alam lang natin ay 200,000. So, ilang million pa yung i-discover natin. And a lot of that nasa Pilipinas kasi very rich tayo doon. Yung ating flora and fauna, nandun din yung mga fungi. So, yun ang ituturo namin, yung basics, fundamentals din, katulad nito, galing sa paano mo kikilalanin ang fungi, paano mo siya bibigyan ng pangalan, paano mo siya ma-isolate, paano mo i-identify, tapos, paano mo siya ipapublish? Paano mo siya bibigyan ng valid na name? At saka, paano ka magawa ng plates para ready na sa publication mo? So, lahat na yan, from isolation to publication, yun ang gagawin namin.
Ayan. So, medyo may kahalo din po itong research, teaching. So, how do you do that? Kasi this is like practicing research. So, how do you discover and essentially identify and publish fungi? Ayan. So,
kasi sayang naman kung hindi mo ipapublish. And that's the goal, right? When you do research, your goal is to publish.
Yep. And also, yun po, itong mga fungal species na to, like we said, like they could some of them have medicinal properties. So who knows, some of them might actually treat cancer one day.
Yeah, and we have a very good, we had an isolate back in Alberta. Nagpo-produce siya nung anti-graft. Yung ano ba yon? Yung transplant na anti-rejection.
Oh, so sa organ transplant. Ayan. Oh, yeah. Baka isa sa inyo kapag na-train kayo diyan, maging baka discover ng
Oo, kasi ang dami talaga sa Pilipinas, nakakalungkot kung hindi natin yung opportunity.
Okay.
I-grab.
All right. So siguro, thank you, Dr. Hiba. So siguro po at this point, I would like to ask Dr. Dabalos, PhST, to send messages of encouragement doon sa mga teachers na nagtuturo ng chemistry and sa mga students who are actually interested, or most especially those who are intimidated by chemistry. Ayan.
Yan. So paano ko ba to i-address yung request ni Jeffrey? So masasabi ko na nag-start yung interest ko sa chemistry kasi noon high school ako, kasi meron akong napanood na chemistry show. I mean, ewan ko kung meron pa ito, pero it's from RPN9, so it's chemistry in action. So isang professor from UP Diliman, no, parang siya yung host, na parang ang galing-galing niya magsalita, tapos nagde-demonstrate siya, tapos pinapaliwanag niya yung reaction. So I would say that there are many digital mga media platforms na ngayon. You just need to just keep on watching, kasi hindi nyo alam kung kailan yung parang moment of inspiration. Hindi nyo alam kung kailan siya mangyayari, that spark. So just continue on and wag kayong mawalan ng loob. Kung say for example nakikita niyo ito, napaka-difficult naman ata ng topic na ito, papaano ko ba? Huwag kayong mawalan ng loob. So actually, you just keep on, you just keep on repeating it, studying it. Maalala ko nung high school ako, meron akong maliit na notebook. I mean, doon ko nilalagay yung mga mahihirap na topics, tapos ng ganyan, kung wala akong ginagawa, I mean, inaaral ko siya ulit hanggang nagsisink in siya. So, I would say that yung science, hindi siya yung pangmadalian na ano. So, the more that you pursue it, hard work, perseverance, actually mas mai-in love ka, and doon talaga na foster yung parang true interest sa science. So, huwag kayong mawawala ng loob kung so feeling nyo na napakahirap naman ito. So, gawin na lang natin, well, I mean, sabihin nyo kay Jeffrey itong mga problems na ito, tapos nang ganyan, maybe makapag-arrange siya ng way in order for us to help digest these things. But thank you very much. Actually, I'm so happy. I mean, yung reception, yung interest ninyo, the type of questions. Actually, kung if only I'm in the Philippines physically, I mean, to stand a blackboard before you, I mean, I would be very happy to address all questions. So hopefully one time mangyari yan, and that would be all thumbs up.
Yeah, I would also like to share with everyone na ako po as a student, I was so inspired by Kuya Chester kasi ang galing-galing po niya talaga. And nung nasa UP po ako, kami magkakaibigan nun. Whenever we encounter challenging questions or problems when it comes to chemistry, alam po namin, pupunta lang kami kay Kuya Chester, babanggitin lang namin yun, and then he will unload. He will really teach you how it's done. So, dun po, kaya ko po to din, the reason why I invited Kuya Chester is because, okay, yung first 4 episodes, well received. But then, gusto ko din pong ipakilala sa inyo that meron pong mga inspiration, yung pong mga tinuturo ko po sa inyo, kinuha ko rin po sa mga kaparehas ni Kuya Chester. So that's how you actually pay it forward. So like the good things that you learn from other people, you share it with others. Pero this time around po kasi, kung nakita nyo po, the way he came up with yung real life situations to teach chemistry concepts na ako na-experience ko po yan sa high school sa Pilipinas. Kung ano lang yung nakasulat sa textbook, kokopyahan lang din sa blackboard, walang masyadong contextualization. Kapag po ganun, hindi siya masyadong didikit. But if you teach chemistry topics as a story, yun po yung kumbaga maalala ng tao. And ito po, sabihin ko sa inyo, kami pong lahat dito, si Dr. Hiba, si Dr. Dabalos, we are all scientists as well. So we were trained to do research. Lahat po ng mga concepts na napupunta dyan sa libro, those are actually results of real-life experiences. Galing po yan sa kwento. Yun pong acetic acid at zinc, bago po yan na-discover, that's from experiments by people like us. Ganun po yun. Ang nangyari na lang po, nung makarating sa inyo, nakasulat na lang siya as an equation. But, kung ikukwento po talaga sa inyo kung ano yung totoong nangyari nun, para ma-discover yung mga chemical reactions na yun, ang mga tao po kasi is more imaginative. So, ito na lang po, magpapakatotoo tayo. Yung mga chismis talagang dumidikit sa mga utak natin. So, kapag po talaga kwento ang pagkakaturo ng chemistry, mas didikit din po yan. So, ganyan lang po. So, hopefully po, in the future, sa mga students at saka teachers, yung pagchismisan na rin chemistry, So,
ibig sabihin, mga marites tayo.
Oo, marites pero STEM. STEM marites, ganyan. Pausuhin natin yan. Alright. So at this point, ay sumakto, saktong 2 hours. We would like to thank Kuya Chester Dabalos for gracing us. We're of course, and actually, I'm not hoping, kasi this will not be the last. Between me and Kuya Chester, I actually told him that our goal in the future is mabuo namin lahat ng fundamental concepts in chemistry in this format. At hindi na siya textbook, para papanoorin nyo na lang na ganito, na nagchichikahan kami, pinag-uusapan namin to. The discussion is actually simplified. Hopefully po na-appreciate nyo that way, na talagang hinihimay po namin. Kasi pag nakita nyo, ay, paano yung CH3COOH, paano yun? So pinakita namin sa inyo, paano siya tinitingnan ng chemist? So dapat na-imagine niyo yung structure. At doon sa structure na yun, isang bond lang talaga ang nagbabago. 'Diba? So maguguluhan kayo na ang dami ng mga atoms na, pero sa totoo lang po yung OH bond lang doon yung gumagalaw. Yan. So hindi po talaga siya mahirap. But then again, kapag yung fundamentals hindi niyo masyadong naiintindihan, everything will be complex. Everything will look challenging. So yun po, 'di ba? Ang yabang po. Hindi, pero ganoon po talaga siya. Polarity, structure, electronegativity, may reason po bakit yan yung unang tinuturo. All right. So at this point, we would like to thank Dr. Chester Dabalos for raising us. And then Mama Connie, thank you so much for being with us today. Actually, si Dr. Hiba, she's in San Antonio, Texas. Bibisitahin niya kami dito. Ako sa bahay ko. Tomorrow. So yan, we're virtually talking right now, pero bukas live po ang bonding namin. So yan. So okay, so at this point, we would like to thank everyone for participating. So ilalagay ko na po sa chat box yung attendance form. Kuya Chester, we would like to invite you to a very quick debrief lang. So we'll be sending you the Zoom link for that. If that's
Thank you, everyone. Thank you.
Maraming salamat po. I will also write down yung attendance form sa comment section sa YouTube YouTube recording nito in case sa inyo baka may ma-miss ninyo yung link. All right, so at this point we would like to thank you all. Saktong-sakto po. We hope that you enjoy your lunch, and in 2 weeks, see you po sa mga interested dun sa Mycology research camp. We're still accepting registration. This is gonna be very fun. I think this is one of the first times na nag-offer tayo ng gantong course for a very cheap price. Kung alam
Maraming kwento.
At saka kung alam niyo lang po kung magkano ang binabayad kay Dr. Hibas. University stock. But ito po talaga, this is more of a public service. And the revenue from the fundraising will be used to fund projects sa PhilSci Hub. So ibabalik din po namin sa inyo yan. So, alright, maraming salamat po. Thank you so much, Dr. Chester. Kuya Chester, I'm glad na na-experience nila yung brand of teaching. Ayan. Alright, thank you everyone.
Bye-bye.
Bye.